Deadlock avoidance. So it is a method which will ensure that the system will never enter into the deadlock. Okay, so system there are some requirements, or we can say prior information needed for avoiding the deadlock. So deadlock avoidance can be the simplest and most useful model it requires is maximum number of resources of each type, and it that means how many resources are there at max and how many are needed more. Okay, so that information will be needed priorly, that means before execution, before process will execute, we need the future requirement for that process, how many resources it needs for its execution in future. Okay, then deadlock avoidance algorithm dynamically examines the resource allocation state to ensure that the system will never go in the circular wait condition. Okay, so how this can be ensured, that is by checking the checking whether the what is the state of the machine after resources allocated to that system. Okay, so before every resource allocation, it will check whether the system is going into the circular wait. If yes, then that request will not be served. Okay, that request will be kept on hold, and then any other request will be served, which is not after serving that request, if my system is not entering into the circular wait, that particular resource allocation will be done. Okay, so let's see what is that state in which the machine is going into the circular wait, or what is that state in which we can say that machine will never enter into the circular wait condition. So we will understand, before starting with the algorithm, we will understand what is meant by safe state. Safe state means ऐसा कौन सा स्टेट है जिसमें अगर मशीन रहेगा तो इट विल नेवर एंटर इनटू द डेडलॉक. Okay, so when a process requests a resource, okay, so system must decide ki whether the immediate allocation will result into the safe state or not. Okay, that means agar maine system has to take the decision, if I allocate the resource, currently requested resource, to that process, then whether my system is in the safe state or not. That means, is there any circular wait condition arising or not? If circular wait is there, we can say it is a unsafe state. Okay, so system is in safe state if there exists sequence, that is P1 to Pn number of processes, that is all the processes in the system, such that each process Pi, the request that Pi can still requesting, resource that Pi is still requesting, that is satisfied by current available resources or resources held by Pj with j is less than I. Okay, that means what is the meaning of this point is, if my process Pi is requesting some resource, either that resource must be available free to allocate to that process with the system. Okay, otherwise, if that resource is not free now, but it is already held by some process Pj, which is going to execute and complete its execution now, and its resource requirement is less than the current process, that is Pi. Okay, so that means Pi को जो resources चाहिए वो अगर system के पास है, then Pi will be allocated with the resource. Else, if the resources requested by Pi are not available with the system, but they are allocated to the process Pj whose requirement is less than Pi. Pi को जितने चाहिए उससे कम उसको resources चाहिए, उसमें से ही some of the resources are requested by Pi. Okay, in that case we can say that system is in safe state. We are going to see this again in more depth with the examples. Okay, so that means if my PI needs some resource that is not immediately available with the system, then PI can wait. कब तक wait करेगा? Till PJ will be finishing its execution, because those resources are not immediately available with the system, and but they are with the PJ, and PJ can release those resources, and those can be given to PI. So PI will be going in waiting state for some temporary time. Okay, so that can be the condition when PJ finishes. So it obviously releases all the resources which it is having. Okay, so PI can obtain the needed resources from the system, because PJ has submitted all its resources to system. Okay, and then PI can execute by accessing all its resources, and it will release all the resources again to the system after its completion. Okay, so all those resources which are released by PI can be accessed by any other resource, that any other process, that is PI plus 1. Okay. So now what is that the facts about the safe state? Okay, so if we say system is in safe state, then we can guarantee that there will never be the deadlock. Okay, when we say system is in safe state, that means there will never be the deadlock. If system is in unsafe state, then there is a possibility of deadlock, but we cannot say there is 100% there will be deadlock. Okay, but there will be a possibility of deadlock. So what this avoidance algorithm will do, it will ensure that the system will never enter into the unsafe state. Okay, that means deadlock आने की possibility ही नहीं रहेगी if I apply the algorithm for avoidance of deadlock. Okay, so second method we will be starting with we can say the second part of first method, that is ensure that the system will never enter into the deadlock. Okay, so उसमें हमने क्या देखा है? Deadlock prevention algorithm already देखा है. Now deadlock avoidance we will see. Okay, now to see or to learn deadlock avoidance, we need to understand the safe state. So safe state is nothing but the state of the system which ensures that there will never be the deadlock. Okay, that means 100% guarantee that there will not be the deadlock. Okay, now what this deadlock avoidance method will do, it will ensure that the system will never enter into the unsafe state. That means there is no possibility of deadlock. Okay, so this is the role of deadlock avoidance algorithm. Now you can observe in this diagram, this is like your Venn diagram. So if you are having all the your universal set, out of that there is a safe state. If your machine goes into the safe state, that can be considered as this part, this gray part. Okay, safe state means no deadlock. Safe state means 100% guarantee that there will never be the deadlock. No deadlock. Okay, and what is mean by unsafe state? Unsafe state means there might be deadlock, but not always, right? So unsafe state का कौन सा region है? That is a blue color region. In that there might be the deadlock. That means some chances are there, but it is not always there. That means sometimes there will not be deadlock like safe state, but we cannot guarantee here. Okay, so यहाँ पर deadlock नहीं है blue region में. यहाँ पर डेडलॉक है ग्रे रीजन में. Okay, but we cannot guarantee if my system is in unsafe state. I cannot guarantee that there will not be deadlock. There may or may not be deadlock, but if my machine is in safe state, I can guarantee that there is no deadlock. Understood this diagram? Understood? Yes or no? Yes. Okay. So let's see deadlock avoidance. Now, deadlock avoidance can be done for two different types of resources. Okay. If my system is having all the resources with single instance, मतलब मेरे पास अगर प्रिंटर है तो एक ही प्रिंटर रहेगा. मेरे पास अगर मशीन अगर इनपुट दैट मीन्स माउस है तो एक ही माउस रहेगा. ओके. सिंगल इंस्टेंस मीन्स एक टाइप का रिसोर्स एक ही नंबर रहेगा. Multiple instances means if I have printer type resource, my system is uh, having or there are two printers connected to my system, connected and installed in my system. Okay. So we can say that there are two instances of printer which are connected to my system. Okay. So likewise, yeah, while avoiding the deadlock, we will be having the two types of methods to avoid the deadlock. One method or first method, when we have single instance of resource, each type of resource in the machine. Okay. At that time, we can use the resource allocation graph. So we have already seen that what is resource allocation graph. Resource allocation graph, it is a graph. We know what is graph. Graph is nothing but set of vertices and edges. Okay. Set of vertices and edges. Vertices means connecting points. Okay. Suppose this is a vertex, this is a vertex, this is a just a minute. This is a third vertex, this is a fourth vertex. Okay. And this is a fifth vertex. Now, these are the set of vertices, and set of edges means they're connecting links. Okay. So now this set of vertices is divided into two parts. One is represented by square, or we can say a rectangle, that is for a resource. So if I have resource type R1, that will be represented as rectangle, and some vertices are, that means vertices are divided into two categories. One is resource and one is process. वर्टाइसिस को हम दो चीजें रिप्रेजेंट करने के लिए यूज करते हैं. रिसोर्स रिप्रेजेंट करने के लिए अगर यूज किया तो स्क्वायर में लिखेंगे, अगर प्रोसेस रिप्रेजेंट किया तो सर्कल में लिखेंगे. ओके. अगर रिसोर्स सी this resource allocation graph is now used to find whether the machine will be in the safe state or not after this allocation, after current allocation of the resource. Okay. And this method is useful to check the whether check the safe state only in that machine where there are resources are of single instance. Okay. तो हम लोग यहाँ पर ये जो रेक्टेंगल है इसके अंदर मल्टीपल डॉट्स नहीं लेने वाले हैं. Why? Because it is this method we will be using only for those machines which are having, those systems which are having single instance of each resource type. Are you getting this? Are you all with me? Yes or no? Yes or no? First method is useful in those systems where the resources are having single instances. Are you all with me?
Yes, ma'am.
Okay. So if in those machines, in those systems, we will be using the resource allocation graph for checking whether my system will go into the unsafe state after this allocation or not. Now we have studied how to draw the resource allocation graph. Now here just the thing is we will not be having multiple instances of resource. That's why in that rectangle we will not be having multiple dots. Okay, that is the only case. Now in that resource allocation graph we know that if there is a age from process to resource, if there is a age from process to resource, that indicates process is requesting for a resource. Okay, and if there is a age from resource to process, that means that resource is already allocated. So we will be just considering these ages. Now in now this age is called as claim age. That means the process pi is now claiming for resource rj. Okay, now claim age converts to the request age when a process requests a resource. Okay, now request age are converted to the assignment age when the resource is allocated. Assignment means that means the r to p, that means resource to process. Okay, this type of conversion will be done afterwards. Okay, when the resource is released by process, that then the assignment age will be reconverted to the claim age. Now let's see this here. This is a resource allocation graph. Now what is the state, what is which are the resources available with process p1? Can you tell me? Yes, can you tell me? P1 के पास कौन कौन से रिसोर्स है और ये कौन से रिसोर्स के लिए रिक्वेस्ट कर रहा है प्रोसेस P1?
Request at R2.
Requesting for R2, right? And which resource it is having?
R1.
R1. Now P2, what about P2?
It's hold R1 and requested to R2.
No, it is requesting for both, na? It is not having any resource because resource to process कोई भी एज नहीं है ना अभी तक प्रोसेस P2 के लिए.
But R1 उससे एग्जीक्यूट मतलब वो होल्ड करके रखा है ना P2 ने
No,
R1 और R2 के लिए वो रिक्वेस्ट कर रहा है ना वेटिंग स्टेट हुआ है.
no. See, if there is a age from process to resource, that is a request age. Okay. If there is a age from resource to process, that is a allocation. This resource is already allocated to process P1. Okay. And this resource P1 is requesting for R2, but it has not received it yet. Getting? Whereas P2 is requesting for R1 as well as R2. Now let's see what system will check. If system has allocated, see both process P1 as well as process P2, both are requesting for resource R2, right? Now if R2 is allocated to P2, If R2 is allocated to P2, then will it be able to complete its execution? No, that is because it needs R1 also, and which is there with P1, and P1 also cannot give it back because it needs R2 for its execution. Okay, so how the system will check the better possibility, that is, suppose that here it will check if this R2 is allocated to P2, then there will be system will go in the unsafe state. That means there can be deadlock. कब डेडलॉक हो सकता है? अगर P1 ने अपना एग्जीक्यूशन कंप्लीट होने से पहले अगर R1 रिलीज नहीं किया, तो देयर विल बी चांस ऑफ डेडलॉक, isn't it? Yes or no? अगर P1 ने R1 जो उसके पास है ये अपना एग्जीक्यूशन कंप्लीट होने तक रिलीज ही नहीं किया, तो क्या होगा? The system will go in the deadlock. So we can say, or system will go in the unsafe state. There is a possibility of deadlock. Okay. Now, what a resource allocation algorithm, graph algorithm will do? Suppose we have process Pi and it is requesting for resource Rj. Then the request can be granted only if after allocation of that resource, the assignment age does not result into the formation of cycle. That means here you can observe this resource is with this resource is it needs this resource, then but this resource is with P2 and but it needs the resource R1, and here you can observe it is forming the cycle. So ऐसा allocation जिसके जिसके ऐसा रिसोर्स अलोकेशन जिसके अलोकेशन के बाद साइकिल फॉर्म हो रहा है, the system will never allocate that resource now immediately. Okay, what it will do, it will check for whether there is any other allocation which is not for framing any, which is not forming any cycle in the resource allocation graph. So that is the resource allocation graph algorithm, and this algorithm is used to check whether the system will be entering into unsafe state or not, and only to those systems which are having single instance of each resource type. Okay, have you got it? Yes or no? Yes or no? रिसोर्स अलोकेशन ग्राफ एल्गोरिदम, इसमें हमें दो एक ही चीज देखनी है कि वेदर देयर इज अ रिक्वेस्ट फॉर सम रिसोर्स फ्रॉम प्रोसेस, देन इफ दैट रिक्वेस्ट इज देयर देन चेक फॉर कि ये रिक्वेस्ट सर्व करने के बाद रिक्वेस्ट दैट मीन्स रिसोर्स अलोकेशन करने के बाद इफ माय ग्राफ दैट मीन्स एक एज चेंज हो जाएगा, रिक्वेस्ट एज विल बी हियर यू कैन ऑब्जर्व ये क्या था, प्रोसेस टू रिसोर्स एज था, दिस वाज इनिशियली प्रोसेस टू रिक्वेस्ट एज, राइट? नाउ आफ्टर allocation it is going to become resource to process, that means resource is allocated. After allocation it is going to change like this way. So system will be checking whether after allocation there is a cycle in the resource allocation graph. Yes, cycle is there. That means system will enter into the unsafe state. That means there might be the deadlock if this allocation will be done to the process P2. Have you got it? What is resource allocation graph algorithm? We will draw the resource allocation graph for all the processes and resources active in the system. Okay, and we will check for the future uh, claim or future request of the resource from all the processes. Okay, and we will check कि वो request अगर serve करने के बाद, that means resource allocation करने के बाद, whether it the because the ages are going to be changed, उसका direction reverse हो जाएगा, so that change in the age, whether it is resulting into formation of cycle or not. If there is the cycle is formed, we say the system will enter into the unsafe state. Okay, have you got it? Yes or no? Please respond.
Yes, ma'am.
Okay, now another type of system in which there are multiple instances of the uh, resource, same resource type. Okay, some of the resources are having multiple instances. So in that system, the resource allocation graph will not help to identify whether the system is entering into unsafe state or not. Because though it is a cycle, more than one dots है, मतलब more than one instances है, तो it can serve the request through other instance. मतलब printer के लिए अगर more than one printers are there, if there though there is a cycle which can be seen in the graph, but since it is having any since it is having one more instance, that can be used to serve the request of other process. Okay, so इसलिए that algorithm, that is resource allocation graph algorithm, is not helpful for us to check to those systems which are having multiple instances, to check the whether the system goes into the unsafe state or not. Okay, so वो machines जिसमें multiple instances है, उसको whether it is going into the unsafe state or not, how to check it, we need some other method, and that other method is nothing but banker's algorithm. Now in banker's algorithm, each process must have a priori claim maximum use. Okay, that means uh, what is the claim, that means a future requirement, and what is the current available resources with each process, what is the additional resources it needs for its execution. So each and every information is needed regarding that process. When a process requests a resource, it may have it that means if the resource is not available with the machine, that then it have to may have to wait. Okay, when the process gets all its resources, it must return them in a finite amount of time. It should not be like कि process को एक बार resources मिल गए तो it is executing forever for long time. There should be some finite amount of time up to which it is going to execute. So वो prior information machine को system को पहले से होना चाहिए for bankers algorithm. Okay, now in bankers algorithm we will be having its practical. बैंकर्स एल्गोरिदम इंप्लीमेंट करने के लिए हमें इंप्लीमेंट करना है हमारे प्रैक्टिकल में. ओके, सो इट bankers algorithm we will be using different data structures. So let us consider that n is number of processes and m is number of resources which are there with the system. Now different data structures like available, max, allocation and need. So all these are of we can say matrix type data structures. Okay, so available means it is like a vector of length m, that means number of resource. मतलब मेरे अगर resources 4 type of resources are there, so R1 के कितने instances available है मशीन के पास, R2 के कितने इंस्टेंसेस मशीन के पास अवेलेबल है, R3 के कितने इंस्टेंसेस मशीन के पास अवेलेबल है, एंड R4 के कितने इंस्टेंसेस मेरे सिस्टम के पास अवेलेबल है. सो कितने नंबर्स मेरे पास होने वाले हैं अवेलेबल में, 4 नंबर्स इफ माय रिसोर्सेस आर ऑफ 4 टाइप. ओके, सो ऐसे like we can say it is like a single dimensional array we can say. Okay, then another data structure is max. Max means suppose I have four type of resources we have assumed. Okay, and 5 processes are there, let us consider. So 4 by 5 that means 20 numbers जो स्टोर कर सके ऐसा मुझे एक मैट्रिक्स चाहिए. मैट्रिक्स मीन्स 2 डायमेंशनल एरे. ओके, सो लेट अस कंसिडर दैट R1, R2, R3 and R4 resources are there. So what is the maximum requirement for process P1 regarding R1, R2, R3 and R4? So yeah, we can have that example here. So take this example. What is max? Max is a matrix. What it shows? Suppose we have 3 types of resource. A is a first type of resource, B is a second type of resource, C is a third type of resource. Now P0 का मैक्सिमम रिक्वायरमेंट क्या है? P0 प्रोसेस का मैक्सिमम रिक्वायरमेंट क्या है? दैट इज 7 इंस्टेंसेस ऑफ रिसोर्स टाइप A. ए टाइप के कितने इंस्टेंसेस चाहिए P0 को? 7. बी टाइप के कितने चाहिए? 5. एंड सी टाइप के कितने चाहिए? 3. सो हाउ मेनी resources are needed or maximum requirement is there for P0? Maximum requirement is 753. That is for resource A, B, C respectively. Likewise P1 को मैक्सिमम कौन से रिसोर्सेस और कितने क्वांटिटी में चाहिए? इट नीड्स ए टाइप के 3 रिसोर्सेस, बी टाइप के 2 रिसोर्सेस एंड सी टाइप के 3 रिसोर्सेस. P2 को एग्जीक्यूट होने के लिए कितने रिसोर्सेस चाहिए? ए टाइप के 9 रिसोर्सेस, बी टाइप के 0 रिसोर्सेस, सी टाइप के 3 रिसोर्सेस. दैट इज नथिंग बट द मैक्स मैट्रिक्स. गॉट इट? The second data structure. Please respond. If you are not getting, you can ask me. Today we are going to finish up with the banker's algorithm. So if you respond quickly, I will be able to finish within 15 minutes. Otherwise, we need to extend it for some 5 minutes. So have you got it? Max matrix. मैक्स मैट्रिक्स का मीनिंग समझ में आया क्या? अभी तक अल्गोरिदम स्टार्ट नहीं हुआ है. वी आर जस्ट अंडरस्टैंडिंग द डेटा स्ट्रक्चर्स, कंटेनर्स जिसमें हम वैल्यूज स्टोर करने वाले हैं. मैक्स मैट्रिक्स में क्या रहने वाला है? मैक्सिमम रिक्वायरमेंट ऑफ एनी प्रोसेस फॉर कंप्लीटिंग इट्स एग्जीक्यूशन. रिक्वायरमेंट रिगार्डिंग रिसोर्सेस. हाँ, हैव यू गॉट इट? आर यू ऑल विथ मी?
Yes, ma'am.
Okay. Now next matrix is allocation. Allocation means, see, suppose करो कि प्रोसेस P फर्स्ट प्रोसेस को R1 टाइप के 10 इंस्टेंसेस मैक्सिमम रिक्वायर्ड है. उसमें से इट इज अलोकेटेड विथ 5 इंस्टेंसेस. उसको कितने चाहिए? R1 टाइप के कितने रिसोर्सेस चाहिए? 10 चाहिए. ओके, आउट ऑफ विच सपोज करो कि 7 आर already allocated to it. Okay, so what is the need? Need means out of 10, 7 are allocated, so that means 3 more are needed by process PI. What 3 more? Resource R1 टाइप के सपोज करो कि प्रोसेस पी को 10 रिसोर्सेस मैक्सिमम रिक्वायर्ड है, उसमें से 7 आर allocated to that process already. So what is the need? Need is 3 more resources of R1 type. ऐसे हर एक टाइप के रिसोर्स का मैक्स, अलोकेशन एंड नीड ये फाइंड आउट करेंगे. सो नीड विल नॉट बी गिवन, वी विल बी सॉल्विंग इट्स प्रॉब्लम्स ऑल्सो, that means numericals also. So need will not be given in your example. You have to calculate the need. You are given with maximum requirement of the resources, you are given with the current allocation of the resources, and you need to find out the need matrix for all the processes regarding all the resources. So these are the different data structures which we will be using in the banker's algorithm. Now Banker's algorithm is used to find whether the system will be there in the safe state after allocation of the resources. Okay, or okay. So a safe state algorithm we will see. So what we will be doing in this algorithm? Let work and finish are two vectors, that is of length m and n. So what is m? M is number of resources and n is number of processes. Now work is equal to available initially, okay, and finish is equal to false for all the processes 0 से लेके n-1, that means all n processes. किसी का भी एग्जीक्यूशन कंप्लीट नहीं हुआ है, इसलिए सबके लिए फिनिश में हमने क्या डाला है? फॉल्स. जिस प्रोसेस का एग्जीक्यूशन कंप्लीट हो जाएगा उसका फिनिश वी विल बी मॉडिफाइंग टू ट्रू. ओके, नाउ वी विल फाइंड आउट एन आई और एनी प्रोसेस पी आई सच दैट फिनिश ऑफ आई इज फॉल्स. मतलब ऐसी प्रोसेस जिसका एग्जीक्यूशन अभी तक कंप्लीट नहीं हुआ है. ओके, ऐसी प्रोसेस जिसका एग्जीक्यूशन अभी तक कंप्लीट नहीं हुआ है, that process we will select any one process, and for that particular process we will check कि उसका need is less than or equal to work. work means available. यहाँ पर हमने ये जो अगर ये allocation नहीं किया है तो directly आप यहाँ पर available लिख सकते हो. So what is the condition? जो भी प्रोसेस मेरा एग्जीक्यूट नहीं हुआ है उस प्रोसेस के लिए I will first find out the need. So how to find out the need? Need can be found by doing subtraction of allocation from maximum. So अगर प्रोसेस को 10 रिसोर्सेस चाहिए, उसमें से अगर allocation means 7 resources subtract किए तो what is need? Need is 3. Okay, so ऐसे हम need find out करेंगे regarding every resource. And if my need of process I जो मैंने अभी सेलेक्ट किया है जिसका एग्जीक्यूशन कंप्लीट नहीं हुआ वो प्रोसेस, सो नीड ऑफ I if it is less than or equal to work, that means जितने भी रिसोर्सेस अभी सिस्टम के पास अवेलेबल है उससे अगर वो प्रोसेस का एग्जीक्यूशन कंप्लीट हो सकता है, then allocate to that. Okay, and if we are not having any such process I, pi, for which either it is, see both the conditions should be true. That means प्रोसेस का एग्जीक्यूशन अभी तक कंप्लीट नहीं हुआ है, ऐसा ही प्रोसेस हमें चाहिए, एंड उसका एग्जीक्यूशन कंप्लीट करने के लिए जितने रिसोर्सेस चाहिए दोज रिसोर्सेस आर देयर अवेलेबल इन द मशीन. अगर ऐसा कोई प्रोसेस आता है तो we will go to the next step, that is we will allow the system to allocate those resources, and we will assume that the process will get completed and we will just do the change in the state of the process. जो हमने सभी प्रोसेसेस को फॉल्स बना के रखा था, अभी क्या हुआ? ith प्रोसेस का finish has now changed to true. Again, this will be continued again and again till we will be able to find out all the I which are having these two things true. वो सभी I जिसके लिए ये दोनों conditions true है, वो सभी I को हम लोग क्या करेंगे, resource will be allocated and then their execution will be completed and we will be changing their finish value to true. Okay, अगर हमें ऐसा कोई I नहीं मिलता है, ऐसा कोई प्रोसेस नहीं मिलता है जिसके लिए फिनिश ऑफ I इज फॉल्स नहीं है, दैट मीन्स सबका एग्जीक्यूशन खत्म हो गया है. इफ फिनिश ऑफ I फॉर ऑल I इज ट्रू, दैट मीन्स सभी प्रोसेसेस जो मेरे मशीन में है, सिस्टम में है, वो सबका फिनिश ऑफ I अगर ट्रू हो गया है, देन वी कैन से दैट सिस्टम इज इन सेफ स्टेट. then we can say that system is in safe state. But अगर सभी processes का finish of I true नहीं हुआ है, but we will not be able to serve their request because उनका जो need है, it is not less than or equal to whatever is available with the system. So in that case, we will say that system is in unsafe state. So this is nothing but safety algorithm. The algorithm will be more clear after solving some examples. But for now, are you getting the algorithm? Why the name banker's algorithm is given? That is because, let us consider you have your bank account. Okay. And आपके account में amount, some amount you are having. Suppose करो कि 10,000 amount is there in your account. And you are in need of some amount. आपको कुछ सडनली आपको कुछ अमाउंट चाहिए एंड यू वेंट टू द बैंक टू विथड्रॉ योर अमाउंट फ्रॉम द बैंक. ओके, what will happen if you ask the amount which is less than the available amount in your account? अकाउंट में जितना मतलब 10,000 आपके अकाउंट में है और आपको अभी जरूरत है 8,000 का, तो क्या होगा? Your request will be served or not? आपका रिक्वेस्ट सर्व होगा कि नहीं होगा? Your account is having 10,000 rupees and you want to withdraw 8,000 rupees. So बैंक वाले आपको पैसे देंगे या नहीं देंगे?
No, ma'am.
Why? Your account is having 10,000 rupees and you want to withdraw 8,000 rupees.
अच्छा हाँ फिर दे देंगे मैम. Yes मैम.
So in that case, your request will be served. But if you are requesting for more amount than whatever is available in your account, in that case, your request has to be denied. So same thing is used by, same logic is used by operating system while allocating the resources. अगर उसके पास operating system के पास अगर resources है, available है, मतलब प्रोसेस का एग्जीक्यूशन कम, मतलब प्रोसेस का नीड कंप्लीट करने के जितने रिसोर्सेस अगर ऑपरेटिंग सिस्टम के पास है, देन ओनली ऑपरेटिंग सिस्टम विल बी सर्विंग दैट रिक्वेस्ट. अदरवाइज इट विल बी डिनाइंग, saying that system will be entering in an unsafe state. This request cannot be served. Got it? So the algorithm is very simple, like the logic which is used in the banking system. That's why the name banker's algorithm is given. So we will see the next part of it and some examples of banker's algorithm in the next class. Okay.
Yes, ma'am.